Welcome to the Occupational Safety Leadership Podcast, episode number 127, with repeat guest Bryan Haywood. So, Bryan was also on episode number 122, where we talked about the differences between the permit required and the non-permit required confined spaces out there. Today, I think I'd like to talk about atmospheric monitoring with Bryan. But before we get started, Bryan, if you could just do just a little bit of background about yourself, and then we'll just get right into it.
Sure. Thank you, David. Been in occupational safety and health and emergency response for about 33 years, going on 34 years, and grew up in the petrochem industry, high risk type of industries, and then been consulting for the last 18 years in high risk environments, power plants, chemical plants, refineries, process safety type facilities. Where confined space has become one of my favorite topics to talk about.
Oh, thank you, Bryan. Thank you. In speaking about today and the atmospheric, speaking about the atmospheric monitoring, what really got me thinking about it was right at the end of 122. We kind of briefly brushed over just how these instruments are going to be calibrated, and when you find that LEL, and really how you go back and actually determine the LEL. I know that we look at the meter and we like to think that meter is what the meter says, but that doesn't always equate. Could you kind of give us a couple practical examples in your experience?
Sure. So as we were talking about reclassifying spaces in the last session, we got into the atmospheric. There's two things before I get too far into it that are just paramount in the monitoring of a hazardous atmosphere within a confined space or permit required confined space, and that is proper calibration of your meter per the manufacturer's frequency and procedures. And the next one that most people, I think we've come a long ways in this category, but we still find the majority of companies are not bump testing their meters before their daily use. And most manufacturers today have really nice little stations that if you buy a bunch of meters, they'll give you these bump test and charging stations. And it's simple as just push a button and the meter goes through a bump test. And it's basically taking the calibration gas, and you're comparing the meter readings to the calibration percentages on the label on the cal gas. And, if it says it should be 19.7 oxygen, then that's what the oxygen should be reading. And it's a very simple, probably 2-3 minute test. But that verifies that the meter is actually functioning properly. Then the next failure mode is the user interface with the meter. And that's where, we get into these discussions. When I do a confined space entry course for entry supervisors, it's a full 8-hour course. And almost 3 hours of it is atmospheric hazards and using the meter, and learning the limitations of the meter. There's people out there, whenever you ask the question in a training class and you say, how much oxygen is in the air right now? You will almost inevitably get the answer 100%.
Right.
And then you start looking at them, you sort of tilt your head and they're like, that's not right. And I'm like, well, you're in 100% volume of air, but this 100% volume of air is made up of 78% nitrogen. And they're like, what? Nitrogen? I thought nitrogen kills people. And I'm like, no, nitrogen's an inert gas. What nitrogen does is it's as simple as fixing it, just displaces the oxygen. And that's that 21%. Really, it's about 20.8 at sea level, but I like to round up to 21. So,
Right.
it's 21% oxygen. And then I tell them this little factor that we use in parts per million and do a lot of it in IH is 1% of the atmosphere is equal to 10,000 parts per million. So, we're at 20.8. If you drop down to 19.8, you've lost 1% of the volume of oxygen in that volume of air. And that means you could have 10,000 parts per million of an unknown chemical inside the space. And if that chemical isn't one of the sensors that's on your 4 or 5 gas meter, you're never going to know it, especially if it doesn't have an odor threshold, or it's not creating an atmosphere that can be seen, like condensing moisture, making a cloud down there. And so, when people sit there and go, well, the permit says 19.5 for oxygen, and if my meter's reading 19.6, hey, 19.6 is better than 19.5. So hop
Yep,
on in there,
exactly.
boys.
Yeah, that's right.
Um,
That's right.
and so not understanding how an atmosphere works, that I tell everybody, it's like, we don't enter these things in a vacuum. They're at atmospheric pressure, and it's 100% volume of air. And if you've lost 1% of oxygen in that space, you really, really should not be putting people in there. And so, as I was alluding to last time, I think it was when you and I were talking, we never use the OSHA ranges in our programs. Our program was basically, 20% to 21% for oxygen. And we'll get to LEL in a minute, but we used like 2% to 3% for LEL.
Mm-hmm,
We didn't
mm-hmm.
use the 19.5 to 23.5. And it wasn't that we wouldn't enter the space. The entry supervisors, who were typically the units or department supervisors, they just weren't qualified to write the permit for that type of atmosphere. And, this is way back in the day when you would have a big facility, you'd have 7, 10, up to 15 safety people on site, and those people would go be the entry supervisor for those type of atmospheres, because it's just higher risk.
Right, right.
So I was trying to train a frontline supervisor who doesn't understand, industrial hygiene terms and parts per million and percentages. We just left it. If it was between 20 and 21, you could write the permit. If it was less than 3 LEL, you could write the permit. But anything outside those ranges, even though it may have been acceptable to OSHA, we didn't let the frontline supervisor write that permit.
Right.
So understanding, how an atmosphere works, that it's 100% volume of air in there, and you want 21% of it to be oxygen and 0% to be LEL, that is your perfect atmosphere. So that covers the oxygen side of it. And rarely will you get an oxygen enriched atmosphere, but you can. Oxidizers actually react and they create pure oxygen. So if you didn't have a perfectly clean space and that space had oxidizers in it and there was water or something causing that reaction, you could get an increase in oxygen. Or you could have a leak on your oxygen acetylene torch inside the space, and that would be putting pure oxygen. So, but most time, the number one killer in confined spaces is oxygen deficient atmosphere. So that's what we spend most of our time talking about. The next one, the LEL. This is one that just, I think I told you last time, I'd probably spent 5-6 years working in the industry. Was pretty confident that I understood confined spaces, had been a rescuer when I was in the fire department, and was big into all the technical stuff. And I can remember we bought new meters from, not to endorse mine safety appliances, but MSA was sort of the brand I grew up on.
Mm-hmm, mm-hmm.
And we bought a whole bunch of these meters. And so they said, well, we'll provide you free training. And so, here's the sales guy or the technical engineer standing up telling us about this correction calculation in the back of their owner's manual. And almost every one of these meters, combustible gas indicators, will have these limitations on an LEL meter. And I like to say the meter is stupid. Okay. The meter doesn't know what flammable gas we're trying to measure for. Right. And for these type meters to work, we have to know the flammable that's in there.
Right.
It's not going to tell us what the flammable, it's not a photoionization detector that's going to tell you what the gas is. It's, you have to know. And, in some facilities, because the vessel processed propane or some kind of flammable liquid. And so you have an idea of, what could be the flammable vapor or gas that's in there. But even when you know it and you get the reading, almost all the big brands will have a table in the back of their owner's manual. And that table will be 2 columns. And then down the left-hand side are all the other flammable liquids or gases, or I should say vapors or gases.
Mm-hmm.
And if your calibration gas was methane, you use the methane column. If your calibration gas was pentane, then you would use the pentane column. So let's say you're going into a space that has xylene, and your meter is reading 3%, right? And
Mm-hmm.
you have sampled. If I don't know if I have time to get into this, but you always sample top, middle, bottom, right?
Mm-hmm. Yep.
Gases will stratify. Some are lighter than air, some are buoyant, some are heavier than air. So you get a reading on your meter. Xylene is heavier than air, so it's going to be at the bottom. And the meter says it's 3%. Well, most people will literally look at the permit and go, oh, wow, if it's less than 10%, I'm okay,
Mm-hmm.
right? And they'll say, go ahead, hop in there. Well, you go look at the correction calculation for xylene, and every company's a little bit different, right? I haven't figured this out, but Industrial Scientific's correction calculations will be a little different than MSA's. They're not too far off, but they're never the exact, because some of these get down to like decimal points of what you multiply by.
Mm-hmm.
And you look and you go, oh, I have to multiply my correction calculation for xylene using methane as my correction calculation. And I don't know if this number is right. I'm just giving you a number to get you over 10. Say it's 3.5. Well, now you multiply 3 times 3.5. Now you're over 10. So now you're entering a hazardous atmosphere. And a lot of companies don't allow you to do that. But people think they're only entering 3%. They do not understand the correction. And I call it a correction calculation. Other companies call them different things, but it's basically the meter doesn't know that it's sampling xylene. And so it's just basically reading that gas, trying to get it to burn and create a pressure. And then the pressure is converted over to a percent LEL, but it's stupid. It doesn't know it's xylene or toluene or acetone or propane or whatever the flammable is. You have to know that. And then you have to know what your meter is being calibrated with. Is it pentane or methane? Look at the right table and then calculate. So instead of having, when I was at Great Lakes Chemical in the mid 90s, we actually made little laminated cards that we basically cut and pasted the MSA table and put it on a piece of paper and laminated and made it front and back. And so a supervisor could pull that out of their wallet, and knowing they're going into a xylene atmosphere, they knew what to multiply it by. And my plant manager, who came from Monsanto and was just a phenomenal safety leader from all rights as a plant manager, he basically said, well, this is ridiculous, right? He goes, why are you trying to satisfy OSHA? If you're worried about the supervisors making this critical mistake, just lower the concentration. OSHA says it's 10. Why can't we use 3?
Right,
and I'm like, well, I guess we can. He goes, if you make it 3 and train everybody and put it on the permit, right? And you tell that supervisor, hey, if that meter is reading over 3, you can't issue the permit. You have to call me or one of the safety engineers from the group. And we will come out and issue the permit. And that's where I learned that little trick. And ever since then, every one of my, VPP sites, we always used ranges much narrower than what OSHA allowed. And it was all because of the limitation of the meter and people not understanding, the true hazards of the atmosphere. And the last thing I'll say is if you're at 9%, 9% is 90,000 parts per million of something, right?
Of something.
Yeah. And you start looking at, well, gee, what chemicals do we have here on site that would be making my LEL meter go up to 9%, and that I'm not exceeding a permissible exposure limit or a threshold limit value, or God forbid, an IDLH at that level, right? So we look at flammable vapor and gases as the primary hazard being, explosive. It's explosive. We tend to lose sight of the chronic, impact. And if you have that much flammable vapor inside the space, you're probably displacing a little bit of oxygen,
Right.
because that's a lot. So, people, most entry supervisors that are not safety professionals tend to struggle with understanding the ins and outs of atmospheric monitoring for confined spaces. So that's why I plug every chance I get is change your oxygen to 20 to 21%, change your LEL to 2% or 3% or less, and you get rid of all these opportunities for someone to make a critical mistake, and let the people who do this for a living and live and breathe this stuff and read everything we can get our hands on about understanding this stuff, let us be the decision maker through some type of risk assessment before we allow somebody to crawl inside that space.
That is a fantastic practice, Bryan. I can think of when I was working for a company that did a lot of sewer work. We specifically had the meters calibrated for methane, of course, and all that stuff. So we didn't worry about a correction factor because we knew that we were finding methane, and
Oh
I
yeah.
think that probably the highest was like 1 or 2%. And I'm still trying to find folks from that company to really go back and make sure that my memory is not foggy, but we would do everything that we could up front to ventilate the space too.
Mm-hmm.
And not just show
Mm-hmm.
up and say, well, whatever the atmosphere is, the atmosphere is. Luckily, because we were working on multiple sewers, you could open up a lot of the sewer lids and really pull a lot of air through there, and that really helped out a lot. So I don't know what it would have been truly bad if we had not done that and just kind of shown up and then taken a sample then. So it probably would have been higher, of course.
Yep. The
And
other thing I'll tell you, if it just in real quick, is we see people ventilating spaces that, I mean, you've got a blower out there that's 100 CFM trying to ventilate a 400,000 gallons bulk storage tank.
right.
And 3 weeks later, you'll be out of there during a turnaround. You'll see them having that same blower on a vessel that's 500 gallons. And it's like, there's a NFPA guide. I don't think they call it a standard. I think it's called a guide. So I want to be accurate in my terminology. But it's NFPA 350.
Oh,
And
okay.
NFPA 350 has taken what I call the slide rule of ventilation. And it's this neat little tool that basically says, okay, if you want 4 air exchanges, right, every hour, or whatever your rate is. I think they base it on 5 every hour, but basically you're getting an air change a full air change every 15 minutes. And it'll tell you the cubic size of the space, and it'll tell you what size blower you have to have. And
Oh, good.
then, if you only had a 1,000 CFM blower, but you wanted to try to, ventilate a 70,000 cubic foot space, then you use that blower. You're only going to get so many air exchanges per hour based on what the blower can blow in there and how big the space is. And it's a really real, I used one that was from NIOSH from, oh my gosh, it had to have been in the early 70s, because it was almost like hand drawn with a ruler.
Right.
That's how old it was. But nothing's changed. The math has not changed, right?
Right.
So NFPA took it and sort of modernized it. So if your listeners are NFPA members, it's an appendices into it's an NFPA 350, and it is a heck of a tool to help people understand. Hey, if I've got a hazardous atmosphere, I just don't set a blower up and blow air in. And you always use forced air. That's positive pressure. That's
Right.
3 times more effective than negative. But how much air do I need to blow in to that size space to actually get an air turnover that, I'm just not doing it to make it look good. I'm actually ventilating the space. So people should be using a tool like that tool in NFPA 350 to ensure that their blower is sized properly for the space.
Right.
So, and again,
Fantastic.
we spend an hour just on ventilating a space. So, yeah, what's forced air ventilation? Where do you blow the air in? Where does the bad air come out? Don't fight Mother Nature. Make sure you got enough flow. Make sure you're getting fresh air from a source. Short circuiting. You're going into a horizontal tank. You got two manways on top open. You got the blower sitting next to one. You're blowing fresh air in the other one. Well, the bad air is coming out right there where the blower's at. So you're sucking the bad air back into the blower, back into the space. So you're basically just recirculating the bad air.
Right.
There's a lot of science to it. And I'm always amazed, as I'm sure you are, when somebody says, yeah, we do confined space training, and they sit you down at a computer for 20 minutes to watch a video. And it's computer based, and it doesn't train the supervisor on ventilation, LEL, oxygen. Doesn't train. It just basically covers the 1910-146 standard. I'm like,
Mhm.
that's why our training is 8 hours for an entry supervisor, right? Is they're going to go through the basic confined space, they're going to go through the entrant, the attendant, and then the entry supervisor training, which is the last 4 hours. And that last 4 hours is atmospheric monitoring, and ventilation, and
Right.
rescue, which we'll talk about rescue in the next episode.
Right. Well, I think that if you were going to do computer based, it's super awesome just to kind of get a little bit of the classroom done, but you really got to do hands on. So I am a perfect example of somebody who can pass any test and has zero experience.
Mm-hmm.
So
Mm-hmm.
you always have to do that hands on stuff then. So, hey, so we're getting really close on time, but before that we go, I'd like to go back to when you were talking about um, sampling of the air and all that good stuff. It mixes strata and everything. Then, so how does a person get their meter or their tube or something down to the bottom, and then kind of factor in that
The pump speed and
speed?
volume.
Yes, exactly,
Yeah.
exactly.
Yeah.
I've watched a couple of folks just thrown a tube in like, yep, it's good. And I'm like, no, it hasn't even made it to the meter yet.
Yeah. And how long do you wait for the meter to actually register? So
Right.
my rule of thumb is, and it doesn't matter what your meter is, and most meters will max length of hose will be 20 foot hose. Some will even be max will be 15. But 5 minutes at each
Hmm.
location. And
Right.
I always ask them a trick, not to give one of my training tricks to your listeners, but so I'll tell them, I said, okay, now it took 5 minutes when the space is 20 foot deep. It took 5 minutes for the gas to get from the bottom of the space through the 20 foot of tube to the meter to get a reading. And then you pull the tube up halfway, right? How long is it going to take for you to register that gas? Because there's a different gas at midway. How long is it going to take for the meter to register that? And almost everybody will go, well, if it was 5 minutes at the bottom and I pull my tube up halfway, 2.5 minutes. And I'm like, no, because it's still going through a 20 foot of tube. It's
Right.
still
Exactly.
traveling the same distance. It's just you're measuring it. And so
Exactly.
those little those assumptions that people make that are wrong are critical in your monitoring a space. So we're talking about ventilation. I see people, because they don't want to carry the blower upstairs. They'll set the blower up on the first floor and blow fresh air into the bottom of the reactor, and the vapor in the reactor is 2.5 times heavier than air. They think that they're going to blow it up and blow it out the top, right?
That's
I'm like,
right.
no, don't fight Mother Nature, right?
Yep.
If the gas is heavier, blow in from the top and let it go out the bottom, but know where it's going, because you're taking a hazardous gas, and you're blowing it out into a process area. You may want to hook up ductwork to the bottom of your vessel and duct that material out to a safe location, because you don't want to gas everybody working on the first floor.
Exactly.
But
Yep.
yeah, the response time, the pull on the pump, all of that comes into play to getting a good sample. But I basically, you get into some of these tall storage columns that are 70, 80 foot tall. That's a little trickier. You need to do an assessment with your manufacturer. There was a great thing that I posted from the UK's HS&E, and it was a fatality investigation they did where the company was using just some regular plastic tubing.
Mm-hmm.
It wasn't the manufacturers, and that tubing had degraded. And as it was degrading, it was causing the meters to have erroneous readings.
Ah,
And so
yes, yes. I've
there,
heard
yeah,
that same thing. Yes.
yeah. And they did a really nice job. And I posted that on it's Safety Engine on LinkedIn and my Facebook group and all that. But I mean, like I said, we've been doing this 30 plus years, and I was like, wow, never thought of that happening. Right.
Mm-hmm. Mm-hmm.
So their big learning thing is, if the manufacturer gives you this spec for tubing, this length, this diameter, and that's what's supposed to go with that pump, you need to stick with that, because you start making changes, and a little change here, little change there, little bit here and there could give you erroneous readings, and that could lead to a disastrous result.
Oh yeah, yeah, yeah. I know that I always bought the tube with the pump because I was always concerned that at some point that if I bought the pump only, I'd have to figure out the whole tube and who's going to carry it and how do you know it's on the truck and all that. So I was like, nope, it's all one kit. I
Yeah.
bought it. It's all in one spot.
Yeah. And last thing I'll tell you is make sure you have that water filter on there, because boy, you get that tube to the bottom and you suck water up into your meter. That's, $5,000, $7,000 gone. So,
Yes,
that
yes.
little water trap is can be a lifesaver to your meter.
Yes, I did go out on a site, and luckily we could kind of see the water coming up. And the guy's like, "Well, how can this be?" I'm like, "Well, you got it in the water, So luckily you could literally see it coming up, and we were able to stop it in time.
Yeah.
Uh, but like the meter had some weird vacuum on it too. Like it didn't really read the oxygen right. It didn't. So right from the get go, you knew something was up with
Oh
this
yeah,
with
because
this
it's
thing
not
too.
it's not getting any gases to
Right, right,
measure across there, because it's all the hose is full of water.
right, right, right,
Um,
right.
so
So, hey, Bryan, we are bumping up on time. If you could spend just a couple of seconds and tell folks where they can find you, connect, and all that good stuff.
Sure. So you can find me on LinkedIn under my name, Bryan Haywood, spelled with a Y. I have a LinkedIn group. My company's name is Safety Engineering, but it's the acronym is SAFTENG, all capital letters. And then of course that's my website, safteng.net is my website. So if people like talking, we have a pretty narrow band in the group. We talk a lot of safety management. We also talk a lot of hazardous materials, code, standards. But most of it's, what I grew up in, chemical, hazardous material type stuff. Join the Facebook group, Safety and Facebook group, or LinkedIn group, or connect with me on LinkedIn, or you can always reach me through my website through text, email, or phone call.
Fantastic, Bryan. Thank you so much for joining us today. So, episode number 127 is complete. Thank you so much for Bryan, for joining us. And you'll be back on in future episodes also. So,
Look forward to it.
episode 127 is complete. Thank you so much for joining me, and have a safe day.